discrete probability distribution tables, working out the mode and median and calculating probabilities. What is the mode of this table? The mode is very simple to work out. Look for the highest probability. So the highest probability here is 0.3. So the mode is 1. Mode equals 1. The mode gives the value of x, which is the most likely. Well, that's based on the value that has the highest probability. What is the mode for this table? Again, look for the highest probability, but there's two of them. Joint highest, 0.3 is there, which means you have two modes, 2 and 4. What is the mode for this table? No single probability is the highest. And all of these are exactly the same, so these values, 1, 2, 3, 4, 9, are all equally likely. This has no mode. The mode for this table, this is the highest probability, so it's 3.1. These values of x are discrete. They will be random variables, so x is still a discrete random variable even though x has decimal values. There's no problem with x having decimal values. These are still fixed values, they are discrete values. The median for a set of numbers divides the numbers into two equal halves. When we look at probability, the median divides the total probability into two equal halves, and total probability is equal to 1, so you have 0.5 and 0.5. To work out the median, start from the left-hand side of your probability table and then work out the cumulative probability. So start adding these probabilities together, and you keep doing this until you reach 0.5 or you pass 0.5, and then you stop. So adding the first two here takes us to 0.2, add 0.15, that's 0.35 so far, add 0.05, so that's 0.4, so we're still not at 0.5. Add on the 0.2, and that takes us to 0.6. So we have reached or passed the 0.5 mark, so now we stop. This is the median. The median is 5. If you do exactly the same thing, but working from the right-hand side of the table, so add up the first two probabilities, that gives you 0.2, add on 0.2, so that gives you a total of 0.4 so far. We still haven't reached the 0.5 mark. Add on 0.2, and this is where you've passed the 0.5 mark, so again you have the same value for the median. The median is 5. The median for this table is slightly more complicated. You have cumulative probabilities again, starting from the left-hand side, so the cumulative probability, 0.2 plus 0.3, you've already reached 0.5 right there. So you look at the x values, and that's suggesting that the median is 2. Now if you repeat the same thing from the right-hand side of the table, so 0.3 plus 0.1, that gives you 0.4 so far, add on 0.1, that takes you to 0.5. So you think, alright, I'm going to stop here, I've reached 0.5, and you look at this, and it gives you a different value for the median. In this case, you have to take the average of these two numbers. So add them together, and then divide by 2. So the median here is 2.5. Calculating probabilities from a discrete probability distribution table like this. So what's the probability that x is less than or equal to 2? Less than or equal to 2 means x could be 1 or x could be equal to 2, which means you have to add up these two probabilities. So the answer here, 0.55. The probability that x takes a value that's greater than 6.2. Look at the values of x. Which values of x are more than 6.2? That's 7 and 8. So you add up these two probabilities to give you 0.04. The probability that x is equal to 3.5. Have a look at the table. Is there a value of x which is equal to 3.5? There's no 3.5 here, which means x will never take that value. It has no chance of occurring. These are discrete values. X will only ever take one of these. 3.5 is not in there, it's not an option. That's why the probability is 0. The probability that x takes a value that's more than 3, but less than 6. So more than 3 and less than 6 are these two. So add up these probabilities to give you 0.11.